Okay, so hello everyone and welcome to this video. So in this video we are actually going to solve one front-end assignment. This is a front-end technical assignment by Vector Shift. Okay, so as you can see, this assignment consists of four parts. Okay, basically I'm going to give an overview of what is this assignment all about. So as you can see that the front end of this web app, so it consists of four nodes: input, LLM, output and text. Okay, so if I just drag this, it's a draggable component. So input, LLM, then output and then text. Okay, so the first part of this assignment is that we need to create like a base layer abstraction for the node. So I will read out the statement. So in frontend/source you will find a folder called nodes. The folder contains JavaScript files for four types of nodes: inputs, outputs, LLMs and text. Okay, so each of these nodes contain different text, contain an input/output connections called handles, and but there is also a significant amount of shared code between the nodes. Currently you could create a new node by copying an existing node into a new file and making modifications, but this approach ends up rewriting significant amounts of code. While this approach is tractable for a small number of nodes, it becomes difficult to maintain as the number of nodes increases. So basically what is actually happening here is that in this app in this app there's actually four nodes. Okay, so all of these four nodes have some shareable code between them. So what we actually need to do is like create a base layer abstraction for these nodes so that we can use that one particular node like any number of times. Like it should be a reusable component. Okay, so that is the first point of this project. Okay, so your task is to create an abstraction for these nodes that speeds up your ability to create new nodes and apply styles across nodes in the future. Once you have created your abstraction, make 5 new nodes of your choosing to demonstrate how it works. Don't spend too long worrying about what the nodes actually do. You should use this as an opportunity to showcase the flexibility/efficiency of your node abstraction. So that is actually saying that after you have created that one particular node, then you can create 5 extra nodes to represent like how it is actually working, how you are reusing that one particular node in order to create 5 nodes as a base layer. Okay, so that is the first part of this problem statement. Okay, now the second part comes to the styling. So this is actually the front-end files you receive do not apply any significant styling. Okay, your task is to style the various components into an appealing, unified design. You can use the Vector Shift's existing style as an inspiration if you'd like, but you are also free to create your own design from ground up. You can use whatever React packages/libraries that you would like. Okay, so that's basically styling of the UI part. Okay, so that I have actually done. So as you can see that this input, LLM, output and text have hover effects as well as linear gradient assigned to it. Like I've changed the colors for all of these four nodes, and then after this we have this toolkit. So if you click on plus, then it will zoom all of these nodes. Okay, and if you click on minus, then it is going to zoom out. And after this there's actually this canvas button, so it works the same thing, and this lockout option. Okay, so this is basic UI. Okay, and there's this submit pipeline button. I'm going to explain you what it actually does, and let's read the third part of the statement. Okay, so now in the third part, like it's a text node logic. So the text node included in the frontend/source/node has field for text input. We want to improve the functionality of this text input in two ways. The first is we want the width and the height of the text node to change as per the user enters more text into the text field, and improve visibility for what the user types in. So basically if the user should type whatever the input inside of that text field, okay, so it should the text area should increase according to the input, whatever the input he is typing. So that is one functionality that you need to create. So as you can see in this text node, I have created this text area. So whatever the input the user is typing, it is going to increase as per the requirement. Okay, so that is one functionality. And the second part is that like if you just write like this and you create some double curly braces, inside of this double curly braces you type like name. Okay, so as you can see there's a left side handle is created. Say simple dot is there. Okay, so this is the functionality that we need to create. So let me read it out loud again. So on the second, we want to allow users to define variables in their text input. When a user enters a valid JavaScript variable name surrounded by double curly braces, we want to create a new handle on the left side of the text node that corresponds to the variable. For example of what it should look like, you can get inspiration from the vector shift text node or watching tutorials using the vector shift text nodes. That is the third part. Okay. So now this is the part which we have included. I've shown you like what it actually means. Then after this, we have to just do the backend integration. So for the backend, they are using Fast API. Okay. So in the backend folder, you will find a very simple Python/Fast API backend. Your task is to build an integration between the front end you completed and this simple backend. On the front end, you should update /frontend/source/submit.js to send the nodes and edges of the pipeline to the this endpoint. Okay, and we just need to let me show you. If we click this submit button, okay, so after clicking the submit button, it should say that like whatever the number of nodes, whatever the number of edges, and is the directed acyclic graph, it is true or not. Okay, so like this you need to just do. So if you just click on like this, we are connecting the nodes. Okay, so let's submit the pipeline. So number of nodes 4, edges 2, and is that true? So it is coming out as true. So this is the whole point. Okay, so actually this was the entire assessment, and this was the entire problem statement for this technical round. Okay, so thank you.